way I solve a problem there, you got me saying attaboy. This is 2126 destroying asteroids. Go Bears. Okay, so you're given an integer mass, which represents the original mass of a planet. Ooh, we can draw planets, guys. Ahaha. So what's Earth look like again? Kind of like that, you know, it's a little blue. It's a blue thing. And then, you know, there's like some green land masses or something. All right. That looks good, right? That looks so good, dude. And then we can draw the planet. Apparently, that looks good enough for me. That's good. Okay. And that has a certain mass associated with it. Okay. You are further given an integer array asteroids, where asteroids I is the mass of the ith asteroid. All right, just to be consistent with the color in here, let's create this asteroids array. And I cannot spell asteroids, asteroids. All right, and then we'll just draw some, you know, asteroids. I don't know what they're composed of. I'm not, you know, some sort of mathematical, or not mathematical, I'm not an astronomer, you know, I'm not a astrophysicist or whatever, you know, whatever the kids are doing these days. I'm just a humble programmer. Okay, but let's create some asteroids here. Okay, maybe they have different sizes, you know, some are small, some are big. You know, maybe this asteroid has size 4, and this one has size 1, and this one has size 5, and this one actually will be 2, and this one will be 1, or something like that, okay? So those are our asteroids, okay? And it turns out that you can arrange for the planet to collide with the asteroid in any arbitrary order, okay? So I guess what that means is, just because 4 is the first asteroid in this list, that doesn't mean that my planet has to collide with 4 first, right? Maybe I take this planet and instead I have it collide with, you know, I don't know, 2 first. And then it collides with 4. And then it collides with 5. And then it collides with 1 or whatever, right? But it doesn't have to go exactly in order. I don't have to collide with 4, then with 2, then with 5, then with 1, right? I have some sort of flexibility in terms of the asteroid that I collide with in the order that I choose to collide with them. Okay. So let's like that here. Now, any arbitrary order. If the mass of the planet is greater than or equal to the mass of the asteroid is destroyed and the planet gains the mass of the asteroid. Otherwise, the planet is destroyed. Okay, so if this planet is larger than the mass of another thing, it gains, it absorbs its mass, right? But if the asteroid is bigger, it destroys its mass, right? So if you had a planet like this, for example, let's say that we created a planet and it has size 3, and there's an asteroid coming at it with size 5, right? In this case, the result will be that the planet is destroyed, right? Because 5 is greater than 3, therefore when they collide, makes sense, right? The larger asteroid will destroy the planet. Okay? Versus if we have a similar case, but the planet is greater, if the planet is greater than the asteroid, well, in that case, we shall see that it is indeed the asteroid which is destroyed, and the planet will absorb the size of the asteroid. So that would be 6 plus 5, 11. Okay. And maybe just make this a little bit bigger to signify that, you know, it destroyed the asteroid. Okay, so that's kind of the example here, right? If we have a planet encountering an asteroid that's bigger, the planet gets destroyed. If you have a planet that's bigger than the asteroid, right? So if smaller than the asteroid, gets destroyed. If it's bigger than the asteroid, it actually absorbs that asteroid's size, becomes larger, and it doesn't get destroyed. Okay? Now I'm going to take this stuff and also just strengthen it down and, you know, maybe leave it over here for sights, but it's not really going to serve any purpose for us at this point going forward. Okay. Now, the asteroid is destroyed and the planet gains the mass of the asteroid, right? So that's this case here. If otherwise the planet is destroyed, that's this top case here. Okay, return true if all asteroids can be destroyed. Okay, so let's go ahead and do the example very quickly because I do not want to spend too much time on this problem today. So let's say we have this planet, right? And it has mass, let's say 10. Okay, so it has mass 10. And then we have our asteroids here. All right, and our asteroids have size, how many do we have anyways? I'm just gonna make them very terrible. I'm not gonna draw them to scale, as if anything was drawn to scale. There's 5, so 1, 2, 3, 4, 5. Okay, and they have size 3, 19, 9, 3, 9, 19, 5, 21. All right, 3, 9, 19, 5, 21. Definitely not to scale because the largest one is the smallest one in this example. Okay, so they're saying one way you can order it to make it work, right, is to, well, if 10 collides with 3, it becomes 13. When it collides with 9, it becomes 13 plus 9, 22. When it combines with 19, it adds that, and you'll see it gets through the whole system, right? So how this works, right, is, you know, I'll just draw out the letters here, right? But it'll just say, okay, so 10 collides with 3 becomes 13. 13 collides with 9 becomes 22. 22 collides with 19 becomes, what's 22 plus 19? 22 plus 10 is 32, plus 9 is 41, becomes 41. 41 combines with 5 becomes 46. 46 combines with 21 and becomes whatever, right? But you see here that this works, right? Because we go through. Versus if we were in this problem and 10 combined with 19 first, we would lose, right? Because 10 would first see 19 and 10 will get destroyed. So, you know, you can tell, obviously, the order of which you choose asteroids will affect whether or not you can do this, right? So we're trying to see if it's true that there's a case, right? Is there a case we can find a certain set of orderings of the asteroids such that it destroys this, that we can destroy all the asteroids and keep the planet intact? Okay, so with that said, let's play the same game here. Okay. All right. Now, let's think about, in this section, how we're going to actually make this work, right? So, how do we know if there's an ordering? How can we kind of logically think through how this is supposed to work? Well, you know, I always want to make sure I'm getting someone smaller than me, right? You always want to make sure that the planet is getting someone smaller than them, right? The planet needs to collide with the smallest person, with a planet smaller than them. With an asteroid smaller than them. Right? Always that's the case. If you're the planet, you need to always be colliding with an asteroid that's smaller than you. Right? That makes sense. I mean, obviously, right? You need to keep it smaller than you such that you don't collapse. So, well, maybe then you should always just collide with the smallest planet in front of you, right? Because the smallest planet is the most likely one to be smaller than you. And if the smallest planet is not smaller than you, then you're screwed. There's nothing you can do. So always collide with the smallest asteroid. I'm sorry, guys. I keep saying asteroid. I mean planet, what I say. The smallest asteroid. Does that make sense? You know, if I'm the planet, I need to always be colliding with an asteroid that's smaller than me. So I might as well collide with the smallest asteroid, because that smallest asteroid is the indicator whether or not I can destroy things. Because if I can't destroy the smallest asteroid, can't destroy anything, I'm screwed. Okay? And also, if you think about it, it's kind of greedy because, well, when I combine with things that are smaller than me, it grows my size, right? So I should always combine with the smallest thing possible, because then maybe later I'll encounter something bigger, but since I've absorbed the smaller thing, I'll continue to accumulate my mass, right? So it's kind of like, the planet may not be ready for all the asteroids. It might not be ready for the biggest asteroid yet. The only way it can become ready for the biggest asteroid is if it absorbs the size of the other asteroids, right? If it absorbs the size of other asteroids. So it needs to, it's like, I'm not ready for you yet, right? But the only way I'll be ready for you is if I destroy other asteroids. So I might as well start destroying the smallest asteroids to get to you, right? So the greedy way of saying that, right, is like, I always destroy the smallest asteroids possible, because that'll give me more points, more mass to destroy later larger asteroids. Hopefully that makes a little bit of sense. It's a greedy approach, and with greedy problems, it's kind of hard to like articulate exactly what's going on, right? But if I had, let's just say for this example, right, we have 3, 9, 19, 5, 21. 3, 19, 3, 9, 19, 5, 21, right? Well, in this case, my mass is 10, okay? So if I'm going to destroy anything, I have to be able to destroy the smallest thing. So I might as well destroy the smallest thing, right? Now, at this point, if I'm going to be able to destroy anything, I'm going to have to be able to destroy the smallest thing, right? So I'm going to have to be at least 18. And then at least 9, 18 plus 9, 27? 27. And at least the smallest thing, and at least the smallest thing. Right? And you might say, well, why not? Why not one of the greater ones? It doesn't matter, right? Because I need to destroy something smaller than me, and anything smaller than me is only going to give me more score, right? So that's the greedy approach. I might as well just destroy the smallest thing, because the smallest thing has to be able to be deleted by me, and the small thing will provide me with more points, which will give me the opportunity to delete the next smallest thing, right? So that's the idea behind this solution. So how does that work functionally? Well, what we have to do, right, is sort asteroids, then simulate. And that's all there is to this problem, right? We sort the asteroids in terms of size, and then we simulate whether or not it's possible to complete this problem accordingly, right? Meaning, if I sort the system, am I capable of actually, taking it through the simulation, right? If I first sort the asteroids from smallest to largest and then go through, can I get through? Because that's the best orientation for me, right? The best orientation for me is that I encounter the smallest people possible as I go through, because I'm trying to maximize my mass as I go through the system. So I should always be able to kill the smallest person. Yeesh, now I'm going to get blocked from YouTube. I should always be able to destroy the smallest asteroid. All right. So that's as best as I can explain it. So let's go ahead and write the solution. So all we got to do is look at each asteroid in the sorted version of asteroids. And then we say, well, if the mass is less than the asteroid, then there's nothing we can do, because this is the smallest asteroid we're looking at. So if I can't destroy this asteroid, I can't destroy any asteroid, because this is the smallest one in the system. Otherwise, I can destroy it, so I add it to my mass. Now it's the same problem again, but for the next largest asteroid. And I'm hoping that since I destroyed the smallest one, I get enough mass to, destroy that one as well. So if I can get to the end with destroying all the asteroids, I return true. And that's all there is to it. All right. Hopefully that works, and I'm not thinking about not missing any edge cases here. But let's think about runtime and space complexity. So, okay. So for let's say, so mass is just a constant. Asteroids, let's say n is the length of asteroids. Okay. All right. So for time, for time, well, we have to look at all the asteroids and asteroids, but we have to first sort asteroids. So that's going to be, let's just say basic, you know, heap sort or, you know, quick sort or whatever. Let's just say it's an n log n sorting algorithm, you know, of course. Always a weird exceptions to things like this. And then for space, well, this, I think, actually creates a new array, so it takes n space. But let's just say, for the sake of argument, you could do an in-place sorting mechanism to sort asteroids, and this would be constant space, because you could sort asteroids in space, and then, you know, all this in here, you're just updating variables. You're not even creating any new variables here. Well, I guess you're creating asteroids, so it's constant space. All right, guys, hopefully that was good. Peace out.